Hello everyone, my name is AJ and I am a backend engineer here at CodeSandbox. Today we are going to talk a little bit about running Advent of Code problems on CodeSandbox. I will talk a little bit more about what both of those things are in just a moment. Today, for day one, I'm going to be working through Advent of Code using the Elixir language, but you have your choice. You can use any language you like, and we'll talk a little bit about how to support those various languages in the CodeSandbox environment. Let's start with talking about Advent of Code. I'm going to pull up Advent of Code here, and let's take a look. So every year, Advent of Code releases some fun little programming challenges throughout the month of December. Your goal is to collect these 2 stars every day. The problems come out at midnight in Easter time in the US, and they usually consist of 2 parts. Part 1 is a, relatively speaking, easier programming problem. It'll give you a fun little riddle with a backstory that basically you're following these elves around the forest trying to pick up these star fruit in order to help the reindeer, feed the reindeer before their big journey on Christmas Day. And you need to perform these various computational tasks in order to help find those fruit. There's always a part 2 as well, in which things get just a little bit harder. For the first few days, usually it's not too bad. It's just a slight modification, usually, of the program that you wrote for part 1. But as time goes on, both part 1 and part 2 get a little more intense. We're not necessarily going to cover all 25 days worth of problems here at CodeSandbox on this channel, but we wanted to show how you can use CodeSandbox as a nice, easy development environment to maybe try out programming for the first time using Advent of Code problems, or try out a new language. Plenty of people use Advent of Code as an excuse to try out a new language they've been meaning to get into, and CodeSandbox is a great way to spin up an environment for that without necessarily having to install everything onto your computer. So that's Advent of Code. We're going to be completing these problems inside of CodeSandbox. CodeSandbox, you may know as a place where you can do a quick little prototype for JavaScript related or front-end web related code and share it with other people. But CodeSandbox is more than that. With repositories, you can import your code from GitHub and have a full development environment in the cloud. So you're not restricted to just front-end web things. You can run backend code like Elixir, which is what we're going to use today. So if you aren't aware of CodeSandbox repositories, do take a look. It's pretty cool. We're very proud of it. We are, as I mentioned, going to work through the day 1 problem using the Elixir language. Now, to get started with Elixir in CodeSandbox, because it's not already pre-installed in the environment, you do need a little bit of configuration. And we want to make this easy for you, so there is a repository available. It's sort of a template. If you go here and you fork the template, you will have a basic Elixir mix project. It's just mix new my app, and it'll get you started writing Elixir code in the CodeSandbox cloud development environment, and you'll be on your way. So I have a repository that is basically this, forked from that template, and I did a little bit of renaming. I called the project Advent for Advent of Code, and it is just what you see here. It's a mix project, and it currently doesn't have any code in it. One thing it does have is that configuration that I mentioned. So there is a file called default.nix. If you aren't familiar with Nix, it's a way to install packages and get your shell environment set up to do basically whatever you want. And in this case, we have just a quick little install script in there for installing Elixir in such a way that it will be compatible not only with the terminals in CodeSandbox, but also the extension host in VS Code. So take a look around that template. If you have ideas for ways that you can make it better, pull requests are definitely accepted, and also feel free to open an issue if you have any trouble with it. We're here to help. So we're currently looking at the main branch of this repository that I have where I'm going to be doing the work. And we want to make a new branch, one that's not the main branch, that's not protected, so we can make changes however we want. Let's go ahead and click branch to do exactly that. It's going to make a fork of the environment that's running this, and it's pretty quick. even though we just made a whole new branch and we have an entirely different development environment available to us. It was almost less than a second. I'm going to go ahead and work in VS Code today. You can do all of the work here in the CodeSandbox web editor if you'd like. There's syntax highlighting available. I want that little extra piece that you get from running the full language server with IntelliSense. And at the moment, the best way to do that is to run the Elixir LS extension inside of VS Code. So I'm going to take a moment and go ahead and launch VS Code. It will take a moment to connect to the environment. We'll just wait for that. And once it does, I need to say, yes, I trust the authors because the author is me. So I better trust it. And we're ready to get started. It's the same code that we saw just a second ago, except now it is running inside of VS Code. It's going to take a moment for me to install the Elixir LS extension. We'll just get that going. And because of the relatively strange way that we installed Elixir using Nix, everything should work with this extension. Even though it's not running a login shell behind the scenes, it's still going to give us IntelliSense if everything works out well. So I'm going to go ahead and open mix.exs. Good news is it has syntax highlighting, so the extension itself is working. And in the background, it's building the dialyzer PLT. So everything is hooked up and connected, and we're ready to go. So what I'm going to do now is go ahead and create a new file where we're going to work through the code of day one, at least part one, and we'll see if we get through part two as well of Advent of Code. Now would be a great time to pause and get your development environment set up if you want to follow along in Elixir. Otherwise, you can just tag along and we'll see the solution for day one in just a little bit. I'm going to create a new file in an Advent folder called day one. That'll be the name of the module. Give that just a moment. And I'm also going to go ahead and create a new folder called input. With all of the Advent of Code problems, they give you an input file for each day. And usually this is something strange, not human readable. Could be a giant list of numbers, things with random letters. It relates to the problem that you're trying to solve. And the files can get a bit big, so I'd rather not just paste them as a string inside the code. And I'd rather not commit them to the repository either, because they are specific to you as a user. There's only a select few input files available, but each user gets a different one of them. So it's not necessarily a good idea to commit it with your code. Looks like dialyzer's done doing its thing, which is great. Input is a great thing to have in git ignore. Looks like I went ahead and did that, so that's good. And we're ready to get started. So in a moment, we're going to be switching back and forth between the description of day one, part one, and the code. So it's going to probably take me a few readings to get through it, and that's okay. And we'll just see how far we get. So let's go ahead and I'll create a little bit of boilerplate here. Just a new module with a function called part one. And this is where we will do the work, whatever it is that we're supposed to be doing for this. So let's now take a read through the problem for day one, part one, and see if we can work through it. There's usually a backstory, as I mentioned, so this explains that you are on a little bit of an expedition with the elves. Your goal is to collect 50 stars by December 25th. Depending on the timing, it may be exactly December 25th, midnight when you do so. Every problem that you do has, again, part one, part two. Each one gives you 1 star. And the rest is a little bit of backstory about this particular problem that we're going to solve. So it says that we are on an expedition on foot. As you begin to approach land, elves are taking inventory of their supplies. One important consideration is food, in particular the number of calories each elf is carrying. So calories is in bold. That's going to be a key word for this problem. The elves take turn writing down the number of calories contained by the various meals, snacks, rations, etc. that they brought with them. 1 item per line. Each elf separates their own inventory from the previous elf's inventory, if any, by a blank line. So in the back of my head, I'm already starting to create this picture, which is actually nicely shown below, of a file that has a bunch of numbers in it. It's going to have all these numbers, a blank line representing that we're now talking about the next elf counting his food, and then another list of numbers. And there's probably going to be a lot of these. This example, usually included in the problem description, is a nice way to test your code to see if you're getting the output that's expected. And the input file that actually gives you the answer you have to submit at the end is usually much longer, or it might even take a much longer time to compute the answer. So the example that they have included here is usually pretty simple. You might be able to work it out by hand, but it's a nice way to test your code. And then you might need to be a little more efficient in your code to actually get the real answer that you submit at the end. So they go through the explanation. So, okay, we have a batch of 3 at the beginning. That's what the first elf is carrying, a snack with 1,000, 2,000, and 3,000 calories for a total of 6,000. 6,000 is also highlighted, so the totals of what each elf is carrying is going to be very important to us. Second elf, same thing. They're just holding 1, 3rd, 4th, 5th. Okay. So in case the elves get hungry and need extra snacks, they need to know which elf to ask. They'd like to know how many calories are being carried by the elf carrying the most calories. So in the back of my head, I'm thinking, okay, we're going to need to take each one of these batches of numbers. We're going to need to add them up because we're interested in knowing which elf has the most. And our answer is how many total calories is that elf carrying. So I have a bunch of elves. They each have a collection of snacks. All those snacks have numbers assigned to them for calories. We're interested in the one with the greatest total, and our answer is going to be what that total is. So you can imagine a variant of this problem where the answer is not the total, but rather which number elf it is, for example. There are many ways that you might have to approach this in similar problems in the future. So, okay, we're going to have a puzzle input that looks a lot like this. Batches of numbers. We need to find the sums of each batch, find the greatest of those sums, and input that as a result. So the example they gave, the answer would be 2,400, and that would be the sum for the 4th elf. So this last or second to last batch of numbers in this example. Okay, so we've talked through the problem. I'm going to be referring back to it plenty, I'm sure. But let's go ahead and get our puzzle input and start working with it. So as I mentioned, this is a much longer file than the example they provided. So in future problems, as they get harder and harder as we work, it may be necessary for us to be a little more computationally efficient with our code because it may take some time to get the answer if we aren't. Let's go ahead and create a new file. I'm going to call it day1.txt, and it's going to hold our input. Easy enough. Okay, and now let's start attacking the problem. Now, I'm a very cautious programmer in the sense that I want to see the output of what I'm doing as we go, so I'm going to be doing a lot of that. Let's just start with very simple hello world. Make sure everything is hooked up correctly. We're getting IntelliSense, so that is a great sign. Save that. I'll open up a terminal over here on the side. It's going to get connected. Okay, and I'm going to just run the code by doing a mix run and give it a command to evaluate. Advent.day1.part1. I'm going to run that as a snippet of Elixir code that we want to run. And by doing it with mix, it's going to compile this entire project first, which is what we want. And we're good. We got hello world back. So now we can start attacking the problem itself. Go ahead and close our input file. We can open it back up in VS Code if we need it later. So we have this big input file with a bunch of strings. and we know in the back of our minds that we're going to be doing some grouping and some summing and a max there at the end. So we're going to probably need to read this file line by line and collect that information in a nice way to make it easier to work with in the future. With Elixir, we have our choice in how we deal with something like this. We can either treat this long list using the enum module. This is where we take all of the numbers in and we deal with all of them at once. So if you do enum.map, it's going to go one by one through all of the items. And then if you call enum.map again, it's going to go one by one all through the items again. That's sort of the eager way to deal with data, long lists of data in Elixir. We could also work with it as a stream. This is the, quote, lazy way of working with long lists of things in Elixir. So we could take this long file as a stream of lines of data, and we can call stream.map instead. And what that's going to do is it's going to break it up so that it does stream.map. For example, if we call stream.map twice, it's going to do stream.map for the first element and then call the mapping function, the second mapping function on that first element. And only when it's done, it's gone through all the things we want to do, then it'll move on to the second element. It'll do mapping function 1, mapping function 2, etc. For this file, it probably doesn't matter because the file isn't long enough for us to be really taking up too much space in memory. But I like working with streams when the option is available, so let's start with that. To put that into code, into practice, one way to read a file is file.stream. It's going to need the name of the file to read, and let's just begin by reading in the file and seeing what that output looks like. So we'll give it input day1.txt. I'm going to call stream.map and ask it to io.inspect all of the elements of that stream. And at the very end, we'll call stream.run. This actually runs all of the map functions for each of the elements at the very end. So let's just start with that. Assuming I've written all that correctly, what we see is the line-by-line stream of each of the lines in that input file. So this is a great start. I'm going to leave that stream.map and stream.run in place, and every time we add another step to process this data, I'm just going to have it output it for us so that we know that we're on the right track. So reading the parts of the problem one more time, these numbers represent calories, and we're interested in which group of them has the greatest total. So I know that we're going to need to process these as numbers so that we can add them up in the future. And that probably means the first thing we need to do is parse them. Let's start with that. We can do this a few different ways. I'm going to try and choose the way that allows us to keep using, stream. Keep using stream.map for as long as possible because it's really nice. So there are, in the back of my mind, I know that there's integer.parse. There's also a string.toInteger. We're interested in whichever one doesn't throw an error if there's no integers present. Because remember, we have these new lines in the middle, these blank lines that sort of divide up the different elves and their collections of food. So let's take a moment. I'm just going to jump down here to the bottom and take a look at integer.parse and string.toInteger. So let's hover over them, use our IntelliSense to give us a clue about how each one is going to behave. And right off the bat, I'm liking the return type of integer.parse because it's going to attempt to parse it as an integer. It's going to not care if there's anything else on that line, which is going to be really useful because notice that each of these lines has a new line character at the end. And it looks like it's going to return an error atom in some cases, which is pretty nice. If the alternative is raising an error and stopping our code, I'd rather have an error atom in this case. So that is looking interesting. But just be sure, let's hover over string.toInteger as well. And it looks like the return type is just integer. And without even reading, oh, there it is. That leads me to believe that the alternative is probably raising an error. And again, we have these blank lines in the middle, so that would probably be an issue for us. So I think integer.parse is the winner so far. So let's go ahead and add integer.parse as one of those functions we're going to run inside the stream using stream.map. Let's see what we have so far. So far, it's looking pretty good. So now instead of a bunch of strings going one by one, we now have a collection of two different things. Either it's a tuple that contains the parsed integer with the leftovers that we don't care about nicely separated out, or it's an error atom. And this just visually, I remember that those line up with the blank lines that we had that were the separations between the groups of numbers. So far, looking pretty good. What I would be interested in doing now is going ahead and grouping everything together. So right now, we're still in a state where we have this nice long stream of data. Now it's time to start chunking it into other things. I know in the back of my mind that there's a function called chunk by. At least I know that there is one on the enum module. The word chunk is kind of what we want to do. So let's see if there's something relevant on the stream module that we can use. So I'm just going to type stream dot, and right there at the top, chunk by. Alphanumerically, it happens to be the first one available to us. So chunk by, according to the doc, says chunks the enum by buffering elements for which the given function returns the same value. So we need a function that's going to change value every time we hit one of those error atoms. So one way to do that is just to check for the error atom. So let's create a quick little anonymous function that's just going to take the element and say, hey, are you the error atom? It's going to auto format for us, which is really kind. Add in those parentheses, and let's see what we have now. This is looking pretty good. So we now have these nice chunks of valid numbers and these little error atoms in their own chunks in between. There's probably a way to change chunk by so that we get the errors at the end or something, or use a different function that would eliminate the errors altogether while still chunking the way we want. I'm not too worried about it if these are easy enough for us to filter out. So actually, let's do that next. So now that we have the groupings that we need, we no longer need the error atoms to be our delineators for each group. So let's do a quick stream.reject. This is sort of the opposite of stream.filter. Very familiar if you've used filter reject from the enum module, doing just the same thing, just lazily instead of eagerly. And we want to reject any element of this stream that looks like one of those problematic parts. So in this case, I think what we want to do is reject anything that looks like a list with just the error atom inside of it. Let's try it. Okay, this is looking pretty good. This is now arranged such that we have this long list of grouped numbers. I'm not seeing any bad data in here except for those new line characters, which we can easily get rid of. And so far, this is looking pretty good. Now, I think we're at the point where we need to start working inside of those groups. I think we've done just about everything we can on the base stream itself. Now it's time to jump into each one of those individual groups and work inside of it. And that is going to be fine. Each group looks pretty small. We're not going to be loading too much into memory at one time. I think we'll be all right, even in later problems where the input files are very large, usually there's a way to break it down so that you're not having to load the entire file or all of the data it represents in memory at the same time. So we're going to work on each group individually now. So that's going to be another stream.map. And I just got a feeling that this map function is going to be a little more complicated than the ones we have had so far. It's not going to be just a quick anonymous function using the shorthand syntax like we've had. And it's not going to be calling something like integer.parse directly. So let's use the non-shorthand anonymous function syntax now so we can spell it out and make things a little more clear. Let's call this the snack list for a given elf. Give ourselves some space to work in, and what do we need to do now? Let's look back at the problem. So we've now grouped it into each group. We are, again, interested in the total calories for each group. So we want to add all of these up. That is a great place to start. Let's just take each group of numbers in the stream, and let's replace it with its total. What do we need to do that? Oh, looks like I need to quickly reconnect. Probably took a little too long doing that. And we'll just wait for a moment. It is different working in the cloud with CodeSandbox. It's not your computer. There are things that you have to understand as you're doing that, because you may be disconnected from the cloud environment because your internet goes down. That actually may be the case with me right now. I'm recording this locally, so if my internet went out, I wouldn't necessarily know it, except for the fact that VS Code disconnected. So that is something to be aware of. If you are trying to work on a train with spotty internet connection, just be aware that it might cut out. But the benefits of working in a cloud environment are pretty interesting. I really like that when I need to work with my coworkers on something, it's really easy to just share a URL with them. Or if you're doing something like this, where you're working on Advent of Code, then it's really interesting that you could have other people join you and code with you. You could pair with people who are not geographically near you on the same code and get the result together. If you're working on an iPad, which is an option, that's also pretty cool that you can run the code and get the results, actually get the answer for Advent of Code without having to figure out a way to run that code on your iPad. So cloud environments, something to be aware of is the potential for disconnection. I'm going to go ahead and close VS Code, but it also gives you a lot of really cool capabilities as well. Okay, we are back to being connected. If you do get disconnected, one cool thing is the state of the terminal still there, all the files and changes still available, so it's very easy to pick back up where you left off. It's not like your computer shutting down and you've lost all of your work without saving. Okay, so we now want to go through, we're going to need to do a little bit of massaging of this data because we have these tuples of the integer and the new line character. So we need to pull out the integers, and then we want to add them all up. And that sum will be the thing that we return from this map function, so that we're basically replacing each group with its total, and then later we can get the max. So let's start by taking the snack list, as I've called it, and let's do now an enum.map because we have a full or a finite list. It's not a potentially very long stream coming from a file. It's a well-known, well-lengthed list. So enum's probably the way to go for this. Let's do just another quick anonymous, or non-shorthand anonymous function. We're going to take the number out of this tuple that we have. Each one looks like this. We're going to take the number out, and we're going to keep just that part of it, because that's all we really care about. And then, actually, let's pause there, make sure everything compiles still, and Okay, so now we no longer have those tuples, we just have these lists of numbers. But we want to go one step further than that while we're inside of this group. We want to enum.sum them together. Now that we're working with numbers and not strings, it's nice and easy to do that. Now, I can't verify that this is correct just looking at these numbers, but these numbers do look much bigger than most of what we were looking at before. So these are reasonably the sums of the things that we were looking at previously. Cool. So now that we have the sums, what we actually want is to identify the max, I remember. So how many total calories is that elf carrying? That elf being the one with the maximum number of calories. So we want the max. Luckily, we don't need to worry about like finding the index of the max or anything like that. We can go ahead and jump out of stream mode now, jump out of lazy mode on evaluating all of this data, and let's call enum.max on it. When you're dealing with a stream, the moment you jump from stream module functions to enum functions, you are effectively ending the laziness in a way. You are forcing it to go through each element one by one and give you an answer. So be aware of that. If you think that you're working with a stream, but you call enum.map, it may not be operating the way that you think. The moment you do an enum.reduce, or in this case, enum.map, or max or sum or something like that, where it has to basically make it all the way through the list before it can give you an answer, you have to work in the enum module, and you will no longer be working with a stream at the end. I'm going to throw an io.puts right here at the end. Let's see what it says. It gives us a number. No idea if this is correct, but the easy way to find out is to submit it. And it is. So this part 1 code was correct. We successfully made our way through each item in the list, did an integer.parse. This is the nice way to do it without necessarily raising an error if something isn't an integer, because we knew that we had those blank lines in the middle that we had to deal with. We chunked them by those lines in the middle, like we just used whether it equals that error atom as a way to distinguish between them. And we rejected all the blank lines that resulted after that chunking. Then we went through each individual group. Now working with enum, we pulled out the integers from the integer.parse results, and we summed them together to get the total number of calories for each elf. Finally, to get the answer for the puzzle, we used enum.max to get our answer and just printed it to the screen. This is pretty cool. Part 1, I'm feeling pretty good. I'm going to take a look at part 2 now, see if we can solve that, and we'll see how far we get. So continue to part 2. Again, with advent of code, part 2 is usually some reformulation or extension on part 1. So the code you wrote for part 1 is often helpful or a nice guide for how to deal with the data, because the input file is usually the same for parts 1 and part 2, but it probably isn't going to get you all the way. You may need to go back and refactor something. So let's take a look at part 2 and see what we need to change for this. By the time you calculate the answer to the elf's question, which we just did for part 1, they've already realized that the elf carrying the most calories of food might eventually run out of snacks. Okay, that would be bad. To avoid this unacceptable situation, the elves would instead like to know the total calories by the top 3 elves. This is interesting. We just got a maximum for the top 1 of those groups of data. Now we're interested in the top 3. enum.max is no longer going to work for us, so we have a little bit more work to do. In the example above, so we're now going to take a look back at this example here with the small example input. We have our top elf that we had before, the 4th elf with 24,000 calories, and then the other 2 were the 3rd and the 5th. So this was the top sum, followed by the 3rd, then the 5th. Okay. So not too bad. Whereas before we did an enum.max to get the top 1, now we want to get the top 3. Now, in later problems for Advent of Code, chances are there will be situations in which the data is so large or the task is so computationally expensive that it would not be reasonable to just go through and find the top 3 in the entire list. It wouldn't be a good idea, for example, to sort the entire list and then find the top 3. For us, I don't know that it's going to matter because the input is pretty small, pretty forgiving for having all that data loaded in memory and sorting it in a reasonable amount of time. So at the start, I'm thinking here we could probably take our same code for part 1 and use it as a basis for our answer for part 2, but just modify it a little bit here at the end where we do enum.max. Now, one way to do this would be to go ahead and call, stream.run or enum.toList. Yeah. Enum.toList is another way to just take it from being a stream into a list like we're used to dealing with. And then we could call enum.sort on it, and we could take the top 3 from that list. So just to demonstrate that really quick, let's go ahead and try that and see if we get the right answer. If we sort by all of the totals, what we'll have at the end is a list that goes from the lowest total to the highest total. We can do an enum.reverse to reverse all of that. You could also sort using a different sort function, so you could change the less than to a greater than or something like that. I always get that backwards, and I never know whether to include less than or equal to or less than or greater than when using a custom sort function. So I'm just going to be a little bit lazy here and say enum.sort, then enum.reverse, and then we're interested in the top 3. So enum.take the top 3, followed by an enum.sum to add them together. I believe that's what we want. Yes, so get the top 3, and then how many calories are those L's carrying in total? Cool. And then we'll just print it out. At this point, especially in the later problems of Advent of Code, I'm usually pretty tired, especially if I'm doing it at night. Ooh, I need to do part 2 now. So I'm kind of rushing towards an answer, and I might be a little more worried about making it more or less computationally expensive later before I post the code online for everyone to judge. Let's see if that gives us the right answer. It does. Cool. So let's go back. That answer 212117 was the correct answer for me. May not be the correct answer for you, so don't worry if you get a different answer because you probably have a different puzzle input. But now let's take a stab at making this a little bit better, or just showing an alternative way to do this calculation. So toList, let's take this portion and try a different way. So I'm imagining that we go through the entire list and we keep a running tally of what the 3 highest are as we go through. There's probably a way to do this that's better than what I'm about to do, but this is just what comes to mind off the top of my head. So we're going to do a reduce, because at the end of this, what we want is we're going to take a large list and bring it down to something small. That's a reduction. At least that's how I think of a reduction, taking a list of n things and coming up with something that's relatively constant sized. So, okay, we're going to take each total and an accumulator. I want the accumulator for this reduction to be the top 3. So it's going to start out with nothing in it, and we're going to find the top 3. At the beginning, it's going to be the first 3, and then as soon as we get to the 4th, we'll add it into this list, and we'll take the top 3 from this smaller list. And we'll keep doing that all the way down the list until we find the top 3 through the very end. So let's call that top 3. Now, what I want to do is let's take and make a new list that has, let's say total, say next total. Let's take the next item in the list and let's add it to the top 3. So we now have a list anywhere from 1 to 4 elements inside of it. And we're going to do basically the same thing that we did before. Sort it. This is a much smaller list to sort, but you do have to keep in the back of your mind that we're going to be doing this sort many, many times. So we haven't really gained anything by doing this. It's just a different way of attempting the same problem. So let's sort it. enum.reverse it and enum.take 3. Okay, so what we have here is, imagine we're somewhere in the middle of the list. We have the top 3 that we have seen so far. We've now taken the next item off the list and added it right at the front. We're going to see if it happens to be one of the top 3 now by sorting all 4 of those, reversing the list, taking the top 3. And what we have at the end is a list of 3 numbers, or if we're at the beginning, we'll have 0, 1, or 2 of them. And we will keep that as our accumulator for the next time this runs. What we have at the end of this reduction, once we get to the end of the list, should be the top 3 elements, the top 3 totals from the entire list, which we can then sum just like we did before, and then io.puts. Again, we've already solved the problem. This is just bonus material at this point. We get the same answer. 2 different ways to think about the same problem. If you are working in a way where maybe you can figure out a way to do this without doing a sort, you just keep the top 3 in a tuple or something, and you have a very computationally efficient way of deciding which are the top 3, then maybe you are able to improve upon this and come up with the answer a bit faster. Not such a problem today, because the first few days of advent of code are usually pretty light to get you into the swing of things, especially if you're using this to learn a new language. As time goes on, it gets a little more advanced and starts taking a little bit more of your time. But that's it for today. This is using CodeSandbox repositories and the cloud development environment in order to work on advent of code in Elixir today, a language that was not previously supported by CodeSandbox sandboxes, but you can definitely work in now with a little bit of help from Nix and setting up the environment ahead of time. I'm not sure how many days we'll cover through this advent of code, but I'm really happy you took the time to join us to see this. I hope you enjoy advent of code. Don't let it be too stressful. You don't have to do everything, especially once the problems get harder. Just use it as an opportunity to try things out, try out a new language, try out a new skill, try out the features of your favorite language that you don't get to use very often. That's it for me today. I hope you enjoyed. We'll see you again very soon.